Today I am having coffee with James Renwick, a climate scientist from Victoria University of Wellington. So could you tell us a little bit about what a climate scientist is?
Well, what I am is originally a weatherman, so I'm more of a, I guess you would say, atmospheric scientist. I study the atmosphere, why the winds blow, where they blow, what's changing about the way the temperature and rainfall and wind patterns in the atmosphere are playing out. I thought I'd talk a little bit about what's known as the Southern Annular Mode, or more colloquially the SAM, S-A-M. It's a really interesting and quite curious feature of the climate of the Southern Hemisphere. So the Southern Annular Mode, or the SAM, is a way of describing how the winds, the roaring 40s and the furious 50s, how they vary over the Southern Hemisphere. So here's my little sketch of Antarctica. That's the peninsula there. New Zealand's up there somewhere. So the Antarctic here is very cold, and the tropics up here are very warm. So there's a big difference in temperature between the tropics and the pole, and that's what drives the strength of the winds. So in the Southern Hemisphere we have these really strong winds, westerly winds that blow all the way around the Southern Hemisphere. And what the Southern Annular Mode is about is just, whereabouts are these winds and how strong are they, because it does vary from month to month. What happens is this big ring of air that's blowing around at 50 kilometres an hour or so, it gradually sort of pulses in and out. So some weeks the winds will move towards the Antarctic coast, and you get draw a lot more arrows quite close to the Antarctic coast, and the winds get a lot lighter in places like New Zealand and Australia and South America. So all of the weather sort of moves southwards, and all the storms that blow around the Southern Ocean, they all contract towards the pole. And in a situation like that, the weather tends to be pretty good over New Zealand. It's sunny, it's settled, it's dry. So we get really good weather when the westerlies contract towards Antarctica. That's what's known as the positive Southern Annular Mode. The weather's pretty positive in New Zealand. It's usually pretty settled and pretty nice. But then the opposite can happen, and sometimes the westerlies actually expand away from Antarctica, and then it can start to blow pretty strongly south of Australia, and the westerlies can get really strong over New Zealand and the southern part of South America. And in that case, you can forget about the sunshine. The weather can get really stormy and unsettled and windy over New Zealand when these westerlies expand out towards the equator. And this is what we call the negative phase of the Southern Annular Mode. And it's really driven just by the occurrence of individual storms. If they start to migrate northwards, then the westerlies will follow them, and you'll end up with this whole system expanding out over New Zealand. And then for whatever reason, everything will sort of collapse back towards Antarctica, and we'll start to see the storms forming much closer to the Antarctic coast, and the westerlies will contract back towards Antarctica. So in the positive Southern Annular Mode, here's a little blow-up shot of New Zealand, Banks Peninsula. Often you'll have a big high pressure system, so the weather map will just look like a big high over New Zealand, and it will be pretty dry and pretty warm over pretty much all of New Zealand. And then in the negative SAM, you'd see big low pressure down here, and probably very strong winds blowing across New Zealand, with probably fronts and rain coming in, so it can be much stormier over New Zealand, wetter, colder, windier. So this thing, it jumps around from positive to negative, every few weeks. There's no particular timescale. It can be 1 week, 2 weeks, 3 weeks, longer. But once it gets set up into one of these modes, it'll sit there for a few weeks at a time. So it has a big influence on our weather from one month to the next. The downside, the catch, is that these changes between the positive and the negative happen basically at random. We can't predict more than a few days in advance what the individual storms are doing. So we can't predict more than a few days in advance what's happening here. It's because it does just come down to just the noisy nature of the circulation over the Southern Ocean, which I don't think will ever be pinned down, and it'll never be able to be predicted a month or two in advance. It's a curious thing. Funnily enough though, there's a longer term feature to the SAM that we are able to understand and predict. Gradually over the last 50 years, we've gone from, say in the 1960s, there was roughly equal chances of getting negative or positive SAM from one month to the next. As time's gone on, we've started to favour the positive SAM a lot more. So a lot more of the months in the last 20 years have been positive SAM rather than negative SAM. And the reason for that is that in the Southern Hemisphere in the last few decades, this difference in temperature between the warm tropics and the cold pole has actually increased. Because with greenhouse gas increase, climate change, the tropical region's getting warmer, like the whole world is, but actually the South Pole, Antarctica, hasn't hardly warmed up at all. Part of the reason for that is something a bit unrelated really, the ozone hole. So in the spring and summer, the ozone over Antarctica mostly disappears, and the ozone in the atmosphere absorbs sunlight, so it warms the atmosphere, having ozone there. You take the ozone away and that cools the atmosphere, so you make the air, at least over Antarctica, even colder than it would be normally. So that increases this north-south temperature difference. While the tropics are warming up, the Antarctic atmosphere has actually been cooling down. So that's caused the westerly winds to blow harder and to contract towards the pole, towards Antarctica itself. So that's encouraged this positive phase of the SAM over the last few decades. That's contributed to the warming over New Zealand, and it's also contributed to a tendency towards drier conditions more often, especially in the spring and summer. What happens in the future is kind of tricky to work out, because the ozone hole is starting to recover, and that would help to warm up the atmosphere over Antarctica, so reduce that difference in temperature. But greenhouse gas increase still happening, so the tropics are still warming up faster than the Southern Ocean and the South Pole. And part of the story is that the warming that we see at the surface of the ocean in most places over the Southern Ocean, it all gets drawn down to great depth. So the surface ocean's staying relatively cool, while the warming's all occurring down at 700, 1,000, 1,500 metres depth. So that's helping to continue to keep it cold down here. So whether or not the ozone hole recovery is going to push us back more towards the negative SAM, or whether the greater warming in the tropics is going to keep us going with more of the positive SAM, this is one of the big research questions for the Southern Hemisphere right now. My suspicion is that the two effects might cancel out, at least for the next 50 years or so, and the recovery of the ozone will sort of counteract the continued warming from greenhouse gases, and we might not see much of a trend. So this tendency towards more of the positive SAM, perhaps that's likely to slow down and stop over the next 10 or 20 years. So we'll still be in a state where there's more of this than there used to be of this. If New Zealand becomes much drier than it is already, that's going to cause problems for farmers and for water supplies, for hydro dams and electricity generation, lots of things, water supplies for drinking. It's going to be a bit of a wait and see. It depends very much how quickly the world reduces its emissions of greenhouse gases, and it's something that I and some of my students are actively working on at the moment.
Could you summarise for us why you and others are researching this?
Well, the Southern Annular Mode has a big influence on the day-to-day and the week-to-week weather over New Zealand and a lot of countries in the Southern Hemisphere. So knowing more about the SAM, both its past and its future, will really help us to plan for the future of the climate and the future of how we're going to operate as a society in a country like New Zealand, or indeed in Australia or any of the other countries in the Southern Hemisphere.
Well, thank you for coming and having a coffee with me on Science on a Napkin.
Well, absolutely my pleasure, and thank you for the coffee.